Hello. Today we will explain a stopwatch Android app created as a task from the Oasis Infobyte internship. Oasis Infobyte introduces a set of internships in many software development fields like web, graphic design, Android, AI, cybersecurity, and more. The link for the website where you can explore them is in the description. Our task is a simple stopwatch application with three main functionalities: start, stop, and reset, with also a feature of adding laps. Let's go to Android Studio and explore the code for the app. In the manifest file, we have added some permissions such as foreground service and post notifications permissions. Then we added the custom application name to perform application-wide initialization. We will need it to provide notification dependencies like Notification Manager and Builder to our service. Finally, we included our service inside the application tag. Here we wrapped constants in one class to serve as a central repository for storing constant values used throughout the application. It utilizes the singleton pattern with the object keyword in Kotlin, ensuring a single instance of these constants. The class includes action strings for starting, stopping, resetting, and adding a lap to a stopwatch service. Additionally, it defines constants related to notification channels and IDs, as well as request codes for handling various click events. This design avoids the redundancy of hard-coding these values across different parts of the application, making it easier to manage and update them in one centralized location. We created a class called Stopwatch Manager to be responsible for managing the state and functionality of a stopwatch feature in an Android application. It utilizes Kotlin coroutines and compose for managing state and updating UI components. The class has properties to represent the current time, stopwatch state, idle, started, stopped, and a list of lap times. The methods include startStopwatch, which starts a timer and updates the time continuously, stopStopwatch to stop the timer, resetStopwatch to reset the stopwatch state and clear lap times, and addNewLapTime to record a new lap time. The class also defines a private function, updateTimeUnits, to convert the duration into minutes, seconds, and milliseconds for display. Additionally, it includes the enum stopwatch state to represent different states of the stopwatch and data classes lap item and time item to encapsulate lap time information and time components, respectively. Overall, the class provides a structured and modular approach to handle stopwatch-related functionalities within the application. The Whistle Notification Manager class is designed to handle notifications related to the stopwatch. It interacts with the Android Notification Manager and Notification Compat Builder to create and update notifications. The class includes methods for setting up the initial notification with a specified channel, updating the notification with stop and resume buttons, updating the notification content with elapsed time, creating a notification channel, and canceling the notification. It also utilizes a custom service helper to obtain pending intents for the stop and resume actions. The class encapsulates the logic for notification management and provides an organized approach to handling notifications in the application. Here comes our Stopwatch Service class for managing the stopwatch functionality within the application. It extends the Service class and includes an inner class Stopwatch Binder that extends Binder to provide a binding interface. The service interacts with the Stopwatch Manager for managing stopwatch state and time-related operations, and the Whistle Notification Manager for handling notifications. The service exposes properties like time, current state, and lapse list to provide access to the stopwatch state and lap information to the UI. The service responds to different actions received via the onStart command method, which is called when the service is started. Actions include starting, stopping, resetting, and adding a lap to the stopwatch. Depending on the action received, it triggers the corresponding methods in the Stopwatch Manager and updates the notification through the Whistle Notification Manager. The service is also designed to run in the foreground when the stopwatch is started, ensuring that it has a persistent notification, and it uses the Start Foreground Service and Stop Foreground Service methods for this purpose. To implement dependency injection without any third-party libraries, we created an interface app module with properties for a notification manager and a notification builder. It is then implemented by a class called Notification Module, which serves as a module for handling notifications in our application. The Notification Module takes a context as a parameter and initializes the Notification Manager and Notification Builder lazily. Then we will initialize the Notification Module in our custom application class and set it as a static property in the companion object. By initializing the Notification Module in the onCreate method of the application class, it ensures that this module is created once when the application starts, and the instance is shared across various components of the application. Our MainActivity class binds to a Stopwatch service to receive real-time updates on the stopwatch state and time. In the onStart method, we initiate the service connection, and the onStop method disconnects from the service. And when the activity is bound to the service, isBound is true, it displays the MainScreen composable that holds the stopwatch UI, including lap lists and buttons for starting, stopping, resuming, resetting, and adding a lap. The service connection callbacks, defined in the connection property, handle the binding and unbinding of the activity to the service. Then, we collect the current state and time from the service and pass them to the MainScreen composable. The interaction with the Stopwatch service is facilitated through the Service Helper class, triggering various actions in response to user clicks on the UI. Finally comes the actual UI, which is implemented using Jetpack Compose. The MainScreen takes in various parameters, such as a list of lap items, the current time, the stopwatch state, and several callback functions for handling user interactions. The screen is structured as a vertical column, with a title representing the app name, a circular representation of the elapsed time, time circle, a lazy column of lap times if available, and a set of bottom buttons for controlling the stopwatch: start, stop, resume, and lap. Let's give it a try and launch the application on the emulator, so can explore its features. Clicking the Start button initiates the stopwatch, dynamically revealing the Stop and Lap buttons. To enhance the functionality, let's introduce the ability to add laps. While the stopwatch is running, users can click the Lap button to record the current lap time. This feature allows users to capture intermediate time intervals without interrupting the overall stopwatch operation. If users decide to stop the stopwatch, they can then choose to either resume or reset it. Resuming the stopwatch seamlessly continues the timer, and the notification feature remains active, enabling users to conveniently control the stopwatch from both the app interface and the notification panel. That's all for our video. Thanks for watching.